So here's a brief overview of the three laws of planetary motion. This video will do the first law, next video second law, and then video after that third law. Now I think there's an example here somewhere, but oh no, there isn't. Okay. So these are the three laws if you just want to know them. The first law: planets orbit their parent star through an elliptical pattern, with the parent star located at the focus of the ellipse, one of the foci. The second law, the radius vector from the parent star to the planet sweeps out areas at equal time intervals. Excuse me. Thirdly, the square of the orbital period is proportional to the cube of the length of the semi-major axis of the ellipse. Now, this all might seem incredibly confusing. It was, especially for me, learning this the first time, but it actually gets fairly okay. We'll do this video on just the first law. So Kepler's first law is fairly intuitive. The way I phrased it might make it seem a bit complicated, but that's because it's quite important and needs to be expressed in full detail. But basically, it just says that a planet's motion is not actually circular to an extent. Um, Depending on the periodicity of the planet, so that means how fast an orbit is. So the periodicity of Mercury is obviously lower than the periodicity of Jupiter, for instance. Uh, it's obviously depending on that. However, the bulge from the elliptical pattern is negligible, so it must be taken into consideration when doing planet near star calculations. So the next diagram that I'm just going to sketch, um, well, there's going to be a quick overview on ellipses first, and then I'm just going to sketch um, what actually this means. So for those who are unaware, ellipses are like stretch circles. They're not ovals. So these 2 points are known as the foci, and the distance by these foci, so d1 and d2, is that d1 plus d2 is actually a constant value for the whole part of the ellipse, which is different from an oval, which is sort of some ovals can be ellipses, but not all. Uh, well, all ellipses are ovals, but not all ovals are ellipses. If that makes sense. So yeah, the distances here are constant values for the ellipse. The focus, which contains no entity, can be ignored. So it's not like the planet is on the second foci. The planet's actually going around the elliptical path, but the second foci doesn't actually matter too much. So the radius vector is the vector pointing from the parent star to the planet, and we will ignore what's known as a planet's actual rotation. So there are two kinds of rotation that I'll just cover real quick. So I'll just actually no, it's a spare page over here. So I'll just do this. So actual rotation is the planet sort of spinning by itself, spinning about that axis. Whereas orbital rotation is the planet orbiting around something else. So it's actually going in this direction here. So actual is rotating on its axis, and orbital rotation is it going through an orbit. Now, there is another quantity called eccentricity. We won't go into that too much. If you read the PowerPoint, well, fair play to you. But it's not necessarily important. It's just it comes up a few times, and we'll actually discuss eccentricity along with this thing called emissivity, which actually has the sort of the same units and sort of same behavior. Anyways, there's another thing that we have to know for Kepler's third law, but I'll obviously discuss that when we get to it. So if you imagine that we have our path here, for instance, so that's a rough idea of the path. Right here is our star at foci F1. And then we'll have the Earth here. So the Earth will always go around the star along the elliptical path. So that's kind of how it goes. The eccentricity is how much something is like a circle. That's not to be considered. A couple of things to note. Now, I sometimes get to mix this up. So let me actually just double check. Yep, okay. So this point here, where the distance is the closest, so once the Earth is here, we'll learn in Kepler's second law, this is the point where it actually moves fastest. But the point that's closest to the star, this is known as a perihelion. And then opposite to this, the point where it moves the slowest, is known as the aphelion. Just things to be considered. So that's really it. Kepler's law just says that a planet orbits in an elliptical pattern with the star at one of the foci of the ellipse.